our class.
OK，老师。
OK，老师。
Let's review about the last class. Last class, I introduced the motor control, DC motor, step motor, and AC motor. AC motor. DC motor, we control the speed of DC motor with PWM signal. This is an example. I give you for your assignment. This diagram you need change. Need to here you need to change. If you want to change here, you can use the battery in the tools, or you can just use the 12V. Replace the battery. L is L29HN motor drive IC. Motor drive IC. Before you can continue your simulation, you need to find how to connect the IC to the microcontroller. You can search online about the pin of the L29HN IC. This is a diagram. I have a test. This diagram can be simulated. This is some introduce about the difference between L293D and L29HN. You can use L293 and or L29H for your circuit. Maybe you can do it both. If you don't want to use the L293D or L29HN, you can just use transistor mated to H-bridge driver. You can make the H-bridge driver by yourself and replace the two IC with H-bridge driver. Step motor. If you want to control the step motor, you need to know how to give the signal to the drive. How to give the signal to the drive circuit. Step circuit. Here. Different drive model. You need different sequence for the drive model. This is a wave drive model. Every time you give one coils, give the signal to one coils. This wave drive model. Wave drive model. It's a full drive model. Every time 2 coins are energized. 2 coins are energized. Half drive model. Half drive model. You can change your program and test the 3 models. Test the 3 models. This is an example to drive the step model. Drive step model with the IC. You can add your own code here. Add your own code here, and with a different drive model. With different drive model. For DC motor and the step motor, they are easy to be controlled. They are easy to be controlled. But let's say it's a little more difficult to control the AC motor. A little difficult to control the AC motor. AC motor. As we know, the speed of AC motor is related to the frequency, supply frequency. So we need to change the frequency. Change the frequency. When we change the frequency, we need to keep the ratio. The ratio V to F is constant. Is constant. So it is difficult for us to control the frequency and the voltage. This is a diagram for the variable speed control. Variable speed control. The 3-phase power is converted to the DC with the rectified circuit. Rectified circuit. Here is DC. DC. After the power is converted to DC, the pseudo 3-phase generator convert the DC to AC to any frequency. Here. So if we want to control the speed of AC motor, we just control the gates of SCR and gates or transistor. This is the output, free output from the variable speed control. Come from here. We call the pseudo 3-phase because the wave is not sinusoid. So we just call the pseudo 3-phase. This is the actual three-phase wave. This is produced three phase using PWM, which means every wave is divided through PWM. We control the PWM. We can control the average voltage for the pursuit three-phase voltage. This is an example of the AC motor speed controller circuit. And this is just one phase, single phase AC motor, single phase AC motor, because there is no single phase AC motor in the Bluetooth, so we cannot simulate this circuit. Cannot simulate this circuit. But
yeah, you said we can't simulate the circuit because it's AC.
There is no single phase AC motor in the Bluetooth software. With no this kind of motor. So there are other components exist in the Bluetooth. Which means other parts of this circuit you can draw in the Bluetooth, but without the AC motor.
Yes, Lashi.
Yeah.
So, Lashi, how can we do this? Is there another application we can use?
So sorry.
How can we simulate this one? Is there another software, or it's okay? No need to simulate. I wanted to know if there's a software that has AC motors.
You wanted to simulate this circuit?
Yeah. If there's a software, maybe that if there's another software that can simulate this one.
You can simulate this software, but you need to change this motor to some other components. Such as you can change this to
the scoop.
This group.
Yeah. Okay.
You can see the wave.
The wave. Okay, no problem.
That's okay. This is introduced about the circuit. Here is change the three-phase to the ending frequency. This is a source. It's a bridge rectified circuit. Converts the AC to DC. Here converts the DC to ending frequency AC. Ending frequency AC. Even it is difficult for us to control the AC motor, but if you want to, you can practice the circuit with the Bluetooth. This is about the review. This review about the last class. because we want to design the mechatronics, key points in the design as to how to control the motor. So that's important for us to know control the motor in the design. You need to design the circuit, design the mechanical, and design the code, design the code, control the running of the motor, of the motor. Next, let's introduce some control systems. This chapter we just give you some conception about the control systems. Control system. Control systems is that is at the heart of mechanical systems. Control systems including control the movement, control the movement, control the motor, control the motor. It is the heart of mechanical systems, and its selection is inarguably by the most critical decision in the design process. The controller selection involves two interdependent parts. Hardware and software. Software and hardware. This is about the conception, control, basic control conception, conception. Open loop, just the forward, control, just the forward control, open loop. Set points to the controller, and the controller gives a signal to the active edge. Active edge drives the process to finish movement, and the controlled variable is the end. Is the end of the control. Is the end of the control. Close the loop control. Close the loop control. This is forward control. This is feedback. This is feedback. The controlled variable is censored by the sensor. And the feedback to the comparator. Feedback to the comparator. This is the closed loop control. Closed loop control. Classification, control systems classification. Control systems are classified by application. Price control usually refers to the industrial process being electronically controlled for the purpose of maintaining uniform correct output. Process control refers to an industrial process being electronically controlled for the purpose maintaining uniform correct output. Perhaps for the simple, we just see the price control, just control the process and the output the correct result. Output the correct result. Motion control refers to a system varying things moving move just control the move control the speed control the displacement several mechanisms is a feedback control system that provides remote control of remote control motion of some object such as robot's arm or radar and antenna radar antenna we can see motion control control the speed control the displacement control the displacement. This is process control if the every component function is the right sequence in the right sequence we can get the right result process control This is a process control example. Mix the blue and the yellow, and get the green. Just the every component, function in the right sequence. We can get the right result. Blue, yellow to the green. Motion control. We either control the speed, control the displacement, control the speed and control the displacement. This is an example for the motion control. CNC machines. When we control the CNC machine, we need to control the speed of table. Control the speed of the table and control the displacement of the table and make it to cut right sharp. Cut the right sharp. CNC machine. Robot manipulate we need to control the end of the manipulate and get the right displacement. Get the right displacement. Right speed. This is a general control systems. General control feedback control systems. This is a set point. This is a feedback. This is a target for the control. This is a interface. Some noise from the outside. Some noise from the outside. Let's review the control systems. This is first order systems. First order. Unit step response of first order systems. This is control systems. This is unit unit step. Unit step. This product we get the response about the unit step response of first order systems. First order systems. This is curves about the first order systems. From the response curves, we can know the some characteristics. It's second order systems. Second order systems. This is a unit step response curves of the systems. Unit step of second order systems. Second order systems. From the diagram, we know the different damper, we can get the different response curves. Response curves. This example is equal to 0. It's 0 0.1, 0 0.2, 0 0.3, 0 0.4. This is damper is equal to 1. This is damper is equal to 2. Equal to 2. From the response curves, we know the perform criteria. Perform criteria. Here is peak time. Peak time. Here is setting times. This is setting times. Setting times. The peak time is the peak. Alcohol, the peak alcohol. The setting time, which means the response is stay in the area, in the zone, is in this zone. We call it is setting time. Here is the rise time. Rise time. The response from 0 to the 1, 0 to the 1. The time we call it response time. Response time. Rise time. Rise time. Next, I just introduced the transistor response. Transistor response. Transient response is the shape of a signal as it moves between two steady state points. Two steady state points. It is quantified in terms of two parameters. The damping region. The damping region. Pronounced zeta. Pronounced zeta. The natural undamped frequency omega n. Omega n. This is damping region, or you can just call the damper. Damper. Zeta. Damper zeta. The damper zeta is the key parameter in the response curves. In response curves. Pole location. Pole location. I'm not sure. You remember the some conception in your control theory. If you remember the control theory, you maybe know the pole location. The pole location is the major factor for a system's transient response. Transient response. pole location. If the pole location is a minus is a minus half plane, we thought the system is steady. System is stable. The system is stable. For everyone, I need to answer this phone.
Okay, Lachi. Okay, Lachi.
Sorry. Let's continue our class. Let's continue our class. The damper region under the lateral of and damped frequency can calculated from the equation. This is a pole. This is the pole. This is the pole. Step response comparisons. Comparisons. This is step. From the figure, we can see if the pole, on the minus on the minus axis, the response curves is like this. Is like this. Which means the systems is stable. This system is stable. If the poise, the pause is on the minus half plane, but close to the axis, we can see the system response curves is rise faster than this one. If the pause is here and here, the systems the response curves is like this. If the pose on the image axis, here, the systems is vibration. Vibration. This response like this. If the pose is on the plus half plane, the systems is not stable. The system is not stable. If the pose is on the plus axis, the response curves like this is not this this systems is not stable is not stable next steady state error steady state error accuracy accuracy is the error between inputs and output signals in the steady state for systems in the steady state for systems. 3 input signals can be used. Step, ramp, and parabola. Parabola. This is a steady state error. This unit step error coefficient this is a ramp unit ramp error unit ramp error this is a unit parabolic error parabolic error this equation we have named in the control theorem. So this is important for us to. It's not important for us to introduce here. You just know some concepts. This is for the different type of systems, different type of systems, there is a different steady state error. Steady state error. Stability. Stability. Stable system is one which produces a bounded or finite response when subjected to a bounded input produce a bounded or finite response bounded or finite response stability condition a system is stable if the real part of all poles are less than zero a system is stable if the real part of all poles is less than zero. A system is marginally stable. If real part of all poles are less than or equal to zero. Less than or equal to zero. A system is unstable if the real part of any pole is positive. A system is stable if the real part of any posit is positive. Here, as we have introduced the real part of the pole, The real part is less than zero. The system is stable. The real part of the pole is equal to zero. Here. The system is marginally stable. Any part, the real part of any poles is bigger than zero. The system is unstable. Is unstable. This is the stability condition. Stability condition. Next, I introduce the control methods. Control methods. Control methods are control techniques and the strategy. The classical control, advanced control, intelligent control. Intelligent control. The classical control, we have named it in the control theorem. Control theorem. But the advanced control and the intelligent control, we haven't named them. Classical control design are used for SISO, single input, single output systems. Most popular concepts are border plots, liquid stability, and the root locus. PID is widely used in feedback systems. Classical control, on-off control. The one kind of classical control, on-off control. This is a simplest method of control. The control action has the three possible outputs: on, off, or no change. On, off, no change. This method is usually used for slow acting operation. Such as refrigeration units. The advantage is it's easy of design and no cost. However, it cannot vary the controlled variable with precision. This is an example for the on-off control. The controlled variable is stated this rule. Classical control, PID control. PID proportional integral derivative. PID, the operation PID is the most commonly used controller for SISO systems. This is a PID control. This is the target. This is a feedback. It's the equation for the PID control. ET is the error. The KP is the gain. The KI is for the integral. KD is for the derivative. Here, this part is a proportional part. This part is the integral part. This part is the derivative parts. So there's 3 parts. Add together. Together we get the output. This is the output. PID control. PID control. This is analog type. This is a digital type. Digital type. PID. PID. If we transfer, Laplace transfer, we can change the equation to this one. This is the PID control. PID control. Analog. Here we can change the analog type to the digital type. This is proportional part. This is proportional part. Here is integral part. Integral part. We can change the integral part to the addition. To the addition type. This is derivative part. We can change the derivative part to the difference. Here is the digital part. Discrete PID implementation. If we get the digital part of the PID control, we can calculate the PID output from the equation. This calculates the addition. This is calculates the integral. This is calculated the derivative. So we can calculate the systems according to this equation. If we want to calculate the this equation, we need to know the value from the key is equal to 0 to the current value. So if we change this equation, this is UK. We can change the UK to UK subtract 1 T subtract T. Here is K minus 1 K minus 1 this is UK. We can subtraction the two equation, so we can get the other part of digital PID control. So according to this type, we can calculate the PID control. Digital control block diagram. control block diagram. This is a digital control block diagram. This the set point converted with AD converts. We can get the digital controller. It's the feedback from the controlled variable. We can change the signal to the digital signal with AD converts. This inputs and the feedback compared here, and the input to the difference equation, and get the results. After we have the results, we change the result from the digital signal to the analog signal with the DA convert. So in the digital control, as we know, we need some attention about the AD and the DA convert. AD and the DV convert. Next, I introduce the advanced control. Advanced control, adaptive control, robust control, and optional control. Adaptive control methods modify the control law used by a controller to cope with the time-varying parameters. For example, as an aircraft flies, its mass will slowly decrease as a result of fuel consumption. We need a control law that adapts itself to such change condition. Robust control. Robust control methods deal with uncertainty. They guarantee that if the changes are within given bounds, the control law need not be changed. Robust control. Optimal control. Use mass optimization method to solve a set of differential equation. Mass optimization methods to solve a set of differential equation. Two such methods are model predictive control or linear quadratic Gaussian control. Intelligent control. Intelligent controllers are used for high-level control. Intelligent controllers are also used when the systems must make decisions based on input data from sensors. Intelligent control is usually used when the mathematical models for the plant is unavailable or highly complex, and available or highly complex. The most two common used intelligent controllers are artificial neural network and fuzzy logical. Fuzzy sets fuzzy set serial provides mathematical tools for carrying out approximate reasoning processes when available information is uncertain or incomplete, imprecise, or vague. Carrying out approximate reasoning process. Fuzzy set theory. Fuzzy logical controller manage complex control problem through heuristics. Just we made a program if then and mathematical models are provided by fuzzy logical rather than by mathematical models provided by differential equation mathematical model are provided by fuzzy logical. Fuzzy logical just when we said something is a little big or medium big or extremely big. This is a fuzzy logical. This is particularly useful for controlling systems whose mathematical model are nonlinear. Or for which standard mathematical models are simplified and are simply not available. Fuzzy control. This is a fuzzy control. Fuzzy controller is consists of fuzzy phi knowledge base interface defuzzy phi. This fuzzy phi converted the input to the fuzzy variable. So according to the fuzzy the knowledge base, we can get the output. The defuzzy phi convert the fuzzy logical to the actually value to the actual value. Fuzzy control. This is the example for the fuzzy control. For example, if theta is positive and theta theta dot theta is positive then is negative is then negative if and then if and then this is the fuzzy logical fuzzy logical hello everyone.
Hello,
We are here
Dr.
also.
Hey, we are here.
Let's have a break.
Okay, Laoshi.
Sure.
How are you hungry?
Sohan, you are fasting. Don't forget.
Lava saying sure, like he didn't eat last 2 days.
He's fasting too.
With who?
Hey. Ego coco.
Ego koko ibisusu.
Ừ. টাকা কিন্তু নাস্তা হইলে ইফতারটা খুব সুন্দর ভাবে হয়। 300 টাকা হইলো বললাম আমার মাকে খাইলাম। আরো যদি 300 টাকা মানে যায় তাহলে মনে করো আমাদের 800, 900, 700 টাকা রাখি থাকি যায়। তো ওই টাকা দিয়ে মনে করো আমরা যে 10 আমরা যদি খুশি অর্ডার দিয়ে খাওয়া যায় সুন্দরভাবে খুশি আমাদের এতটা টাকা খুশি লাগবে ডিম দিয়ে খুব সুন্দরভাবে ডিম দিয়ে খুশি
Hello, brother. Can you?
পুরো করা হবে কেমন তো বিরিয়ানি করি কাজ কাজ কাজ
Hello.
Yes, Lasse.
Hello,
Um,
Laushi.
Let's continue our class.
Okay, 老师。
Last class, we talk about the fuzzy control. Fuzzy control. This is an example for the fuzzy control. Fuzzy control. If theta is a positive, theta is a positive. A positive. And theta dot is a positive. The U is U negative. Is U negative here. If theta is negative and theta dot is negative, U is positive. U is positive. You give you some condition for decide the field of fuzzy variable. Here is intelligent control. Intelligent control. The typical intelligent control is artificial neural network. Artificial neural network. Non-linear mathematical models that are used to mimic the biological neurons in the brain. Mimic the neurons in the brain. ANA are used as a black box model to map a neuron function. Used as a black box. And ANA can be used for identification and control. Identification and the control such as face identification. This is a single Newton ANA single Newton. These are inputs these are outputs the inputs are inputted to the single Newton and generated the output generate output is using is some kind of function operates on this input and generates the output This is a neural network many inputs and outputs are inputs to the network before this variable are inputs to the net they are pass through the target distribution learning TTL. This element divided the variable to different kinds. This variable are inputted to the first layer and operated by the neural function and the variable passes through the second layer and operated by the neural function and generate the output these elements work like the black box we need to know or we don't know the actually what did they do we just passes through the net passes through the net and generates the outputs mostly the output will generate the best result this is an artificial neural net identification and control this is a control part this is identification and this is put this two function together put the two function together this control the target this identification the target identification the plant and get the approximate model for the systems this is another example for the identification and the control identification. This part is a neural network plant model. This is neural network controller. In the ANN, the identification can produce a approximate model to represent the target plant. The neural network controller work like the microcontroller control the systems, control the systems. This these are intelligent controller application. Controller application. The vehicle move on the road on the road and can according to the different condition. According to the different condition. The central part is motion control systems. Motion control systems. The sensing and the perception systems gives the safety reasoning, terrorism assessment, and strategy navigation to the motion control systems. Motion control systems produce the control strategy. Control strategy. This is an intelligent controller application. Intelligent control. This is like the moon vehicle. Moon vehicle. These systems include low level PID control for the velocity control, high level intelligent control, fuzzy control for decision making, neural net for imaging analysis, image analysis, image analysis. Next, I introduce the hardware. Hardware controller. Hardware controller. As we know, the control systems are divided into two kinds of control: analog and digital. Analog, digital. The analog, the different kind of control model use different kind of methods. Different kinds of methods. The analog use if the system is time variable. Time variable. Use continuous model. Continuous model. The digital use discrete model. For the time equation, for the time equation, the analog model use differential equation. The digital model use difference equation. Difference equation. For the frequency transforms. Frequency transforms. The analog model use Laplace transform. Transforms. The digital model use Z transform. Z transform. For the stability, for the system stability, the analog use pulse on the S plane. Pulse on S plane. The digital use pulse inside the unit circle. Pulse inside unit circle. Unit circle. For the control system controller, the analog systems use operation amplifier. Operation amplifier. No need. Didn't the software. Didn't software. But the digital model needs hardware such as some kind of microcontroller and the software. The controller hardware microcontroller. The criteria for choosing controller price, size, and weight. Price. We maybe choose the cheap as possible, as cheap as possible, as cheap as possible, as cheap as possible for the price. The size, maybe we need a smaller size, and smaller weight, Number of digital inputs and output. This criteria is from the target, control target. And the numbers of analog inputs and outputs. This is from the targets. Speed. This speed and control speed. Required interrupt. Required hardware. The interrupter. This concept we have learned is last semester. Communication interface. Then we will decide if communication is needed. Reliability. If the system is unstable, the system cannot work. Memory. This is according to the system's code. Programming capability. Software support. These are criteria for choosing controller. Hardware controller. The microcontroller. The PLC. Programmable logical controller. DSP. Digital signal processor. FPGA. Field programmable gate array. PC with DAQ. Data acquisition. This are the hardware controller we can select for our control systems. We will introduce the PLC. In the next class. Microcontroller is a special type of small computer that can perform a specific job. Microcontroller is a computer on chip. It is an integrated circuit that contains microprocessor, memory, I/O ports, and sometimes AD converters. It can be programmed using several languages such as assembly or C or C++. It can be used in manufacturing lines, but requires additional hardware. Microcontroller mainly are used in engineering products such as washing machine and air conditioner. Air conditioner. These are microcontroller companies. Controller companies. Motorola. Intel. Renaissance. 8-mil microchip and Texas Instruments. Texas Instruments. Next, I introduce the Arduino. Arduino is an open source electronics prototyping platform based on flexible, easy to use hardware and software. The hardware consists of simple open source hardware board designed around an 8-bit 8-mil AVR microcontroller. Though a new model has been designed around 32-bit 8-mil ARM. Arduino is a open source hardware board. You can program this board and make your own function. It's Arduino. ARM. The ARM architecture described a family of RISC-based computer processors designed and licensed by British company ARM Holdings. As an IP core business. IP core intellectual property core is a block of logical or data that is used in making a field program gate array or application specific integrated circuits for a product. IP core is a block of logical or data. IP core business is ARM holding itself does not manufacture its own electronic chips, but license its design to other semiconductor manufacturers. This is the business of ARM holding. They just design the IP core and sales or license to other manufacturer. PLC. A PLC program or logical controller is a specialized digital controller that can control machines and processes. It monitors inputs, make a decision, and control outputs in order to automate machine and process. The PLC can control the light on or off, control the motor speed, control the pump, accept the input from the button, from the button and control the photo sensor get the result from the photo sensor. So the PLC get the result from the outside and give a decision to the target give a decision for the target programmable logical controller PLC are user friendly micro processor based specialized computer specialized computer that is used for process control from here we know the PLC consists of a microprocessor. It contains input module for approximate sensor actuator interface. It is mainly used in automated manufacturing lines. The PLC is usually used for single logical operation. It is considered reliable and easy to program. Also, the PLC contains microprocessor, but the programming is different from the microprocessor. There are the special programming language for the PLC. Use neither diagrams, instructions, or function block. These three types of language for the PLC. These are the PLC manufacturers. PLC ABB Boss Mitsubishi Siemens Ohms Penny Makuki Toshiba. These are the PLC manufacturers. Let's have a comparison about the PLC and the microcontroller. Usually, PLCs are used in individual industrial environments. Whereas the microcontrollers are smaller and well suited for embedded situation. This is a microcontroller. PLC in the industry environment. PLCs are programmed with ready-made block. All programming elements whereas in microcontroller, a programming language must be used to write programming code. we need to write everything for the microcontrollers, but we just use the ready-made block for the PLC. PLC advantages. What advantages are? They are highly reliable, fast and flexible, They can handle several conditions such as dust, humidities. They can communicate with other controllers. They are easy to program and troubleshoot. They include displays units. Okay, everyone.
Yes, Lashi, we are here.
Hello, Lassie, we are here.
Let's have a break.
Yeah. All right, Lassie.
Yeah.
Thank you.
Around.
It's a lot today, lava.
No, Swan, don't start that a lot. Today we are not ending the class early.
What do you mean?
We are here to study. No complaints.
I said only for lava. It's not for me or you.
No, you.
For
Are
a
you
special
me?
one, it's lava.
Are you me? Why are you saying about me?
Bro, I care for you.
História da esposa de Jesus. Porque pense, se tiver festa na tua casa e a bebida acabar, não tem. Imagina que você vai com a tua mãe em minha casa e a tua mãe e a minha mãe e vocês estão a conversar. E tem festa na minha casa. Se acabar a bebida, a quem vocês acham também?
Lava, mute yourself, bro.
Oh, sorry.
Se eu fizer a
What the heck? I was thinking of going to school. And like enough I didn't.
Yalele, I knew that you were planning. How was that?
How did you know? You saw me sitting here. You just think the guy might be in another mood.
But I just went there and I don't know. Very cool. When I saw you the way you was looking up, it was like, let me go. Before the same spirit people telling you yesterday, like today, man, you are still in these things and what?
yesterday I was talking to you. Right. I wanted to destroy you. Then you cook another. If I find you not in the kitchen. Charlie, I come and you are destroying my hand. And the other one you showed that us to be told. It will be the third word. You know this guy, Albert Einstein. He said before he died, he said that he's not sure about what the weapons will be used in Third World War, but he's sure of what will be used in Fourth World War. You know what he said? He said the sticks and stones. Why? Was it wrong? Because what he was trying to explain is now that the world has known about uranium, he declared that he introduced this uranium bomb to the US. And he was like, what he wanted to say is like the third world war is going to be the nuclear weapon war. So the fourth world war, nothing will be there to use. Only stones and only stones and sticks. Everything will be subtracted into that world war. Then extend that only stones and sticks will be left behind. This sheet is this.
This is not for hand. This is not for hand, bro. You have to. It's not even warm up. It's not for hand. It's for squats. It's for squats. Don't squat or deadlift. But if you use or hips. Huh? What?
Big boy. What big boy? Who is the owner of this?
Don't have to know. Actually, we don't know the owner. We are all just using it.
Planning for it.
I'm planning for it.
This nigga is planning for everything.
Everything is planning.
You make your plans before. Yes. One is telling against you. You say, oh, I lift this sheet. Wow. It's not that big deal. It's not that big deal. Nobody will see anything.
Hello.
Yes, Lachi.
Let's continue our class.
Okay.
Last class I introduced the PLC advantage. PLC are reliable, highly reliable, and easy to use. Easy to use. Handle severe conditions. Severe conditions. Next, digital signal processor. Digital signal processor. Digital signal processing is arithmetic processing of discrete time signals. Discrete time signals. Digital signal processor specialized microprocessor with advanced architecture such as multi-buses, parallel processing, hardware multipliers, and fast sampling rate. That are designed to reduce the number of instructions and operations necessary for efficient processing. Which means DSP has a higher efficiency, than the microcontroller. DSP chips enable developers to implement complex algorithms and perform computationally efficient and faster algorithms DSP are preferred over microcontrollers when they're needed for complex and iterative control to control algorithm is required. Complex and iterative control algorithm. The important characteristic for the DSP is its operation convolution. The convolution requires reflection, shift, multiplication, and addition. This is the operation. The equation like this. DSP architecture features parallel processing, modified hardware. And as we know, the computer has two model. The Harvard model and the von Neumann model. The Harvard model, the memory for the data and the code is different. The von Neumann model, the memory for data and code is the same memory. Deep instruction pipeline. very fast AD convert hardware multiplier. Hardware multiplier is faster than the software multipliers. Barrel shift and RISC reduce the instruction set computer reduce the instruction modify the hardware architecture a architecture employs separate program and data buses to access separate data and the program memory and modify the hardware architecture DSP multi-pair data buses and the multi-pair associated drives buses so that the processing of two signals can be done in parallel. The drives buses are also separate. The drives are separate. This multi-pair bus arrangement increases the speed since instruction and data can move in parallel, and execute simultaneously rather than sequentially. The modified hardware architecture. This is a diagram for the modified hardware architecture. Memory A for memory B for B address So the multi-pair ifs for the ALU this accumulator server the A and B this shift and move the result to the memory C So there is different memory for the calculation Its features are instruction pipeline. Instruction pipeline is a technical of organizing the instruction for execution in such a way that execution of current instruction is overlapped by the execution of its subsequent instruction. Instruction pipeline improves the performance of the processor by increasing its throughput, i.e., number of instruction per unit time. This is a comparison for the sequence and the pipeline. Sequence this instruction 1 and the instruction 2. After instruction 1 is ended, the instruction 2 is started. But in the instruction pipeline, instruction is started when the instruction 1 is executing. The instruction 3 is started when the instruction 2 is executing. So the output is produced with the minimum interval, which means here is the output, here is the output, here is the output. But for the sequence execution, the output and the X output, the interval is big in this bigger than this This is a instruction pipeline The DSP up to 6 level pipeline 6 level which means this can go to instruction 6 DSP can execution instruction in parallel Overall execution times are accelerated so that high speed. Hardware multipliers. For 16 by 16 bit hardware multipliers and store result in a 40 bit accumulator 40 bit accumulator in a single instruction cycle in a single instruction cycle Thus multiply and accumulate operation can be performed in a single clock cycle in DSP. As we know, the multiply and multiply algorithm in the microcontroller, the algorithm need four clock cycle but in DSP needs a single one clock cycle Conventional processor may require 10 of cycle for this operation maybe 10 I said 4 is less maybe you need 10 maybe you need 10 Shifter and RISC hardware shifters no scaling prevention overflow and maintain required precision and on-chip hardware stack reduce interrupt response response time and minimize stack pointer manipulation. DSP uses reduced instruction sets tailored to digital signal processing operation. For example, this command in the PSP MACD implements 4 operations in one instruction. Multiplies 2 values, move date, add the product to a previous result, transfer the results and to an adjacent register. Next, introduce the digital signal controller manufacture. This is Texas instrumentation. Texas instrumentation. The typical products DSP. The microchip. The PLC. Motorola. The user can ask the manufacturer to customer made DSP engine. Next, introduce the field programmable gate array. The field programmable gate array is a semiconductor device that can be programmed after manufacturing. Instead of being restricted to any predetermined hardware function, an FPGA allows you to program product features and functions adapt to new standards and reconfigure the hardware for specific applications even after the product has been installed in the field. Hence, the name field programmable. FPGAs can be used to implement any logical function that an application specific integrated circuits could perform. One advantage is its ability to update the functionality after shipping. FPGAs vs microcontrollers. FPGA can perform concurrent operation while the microcontroller operation are sequential. This makes FPGA better suited for real-time application such as executing DSP algorithm. FPGA are flexible. You can add subtract the functionalities as required. This cannot be done in microcontroller. You can add or subtract the functionalities. FPGA are hardware under the random attack of alpha rays cannot destroy corrupt the memory area, hence collapse the device's functionality. The random attack of alpha rays cannot destroy memory. FPGA based development is longer, while microcontrollers change too often, and here there is not rework required to do in order to keep pace with changing technology. This is necessary to save the design from being obsolete. The development time for microcontroller is shorter and that of FPGA. The microcontroller peripheral are readily available and tested by the vendor. As for the FPGA, open source software peripherals are available. but still need to be embedded and tested. Microcontrollers are power efficient. Microcontrollers are no cost are much lower than FPGA. This is especially true for small application and large quantities. Microcontrollers are available in easy to solve SOIC and QFP package. And while FPGA offer limited sources. This is a packaging model for the semiconductor. The microcontroller there's two package, while the FPGAs they are limited. Sources. Next, introduce the personal computer. Everyone maybe you need know how to use the personal computer. Personal computers are used when extensive signal processing and in-depth analysis is required. Extensive signal processing, in-depth analysis, this will require data acquisition card, to interface the I/O power and the signals between the PC and the environment. Advantages are including superior graphic and software flexibility. We use the PC and know the advantage. However, the cost is high, and therefore they are not suitable for large number of products. As we know, the PC is expensive, but the microcontroller is very cheap. Another disadvantage is the speed. Sometimes the PC the running speed is not fast. This is example is PC and the DAQ data acquisition card. This acquisition card. If we want to use the PC as the controller, we need the DAQ data acquisition card. We need the data acquisition card. Lastly, we summarize the chapter. This chapter. The selection of the controller is arguably the most important issue of the mechatronic systems. This choice can be divided into two parts. One, software and firmware algorithms. This is some algorithm. On-off algorithm, PID, adaptive, robust, optimal, and intelligent. This is all the algorithms. Hardware's selection. Microcontroller, PSP, PLC, DSP, FPGA, and PCDQ. You need to decide which one to choose, which one to choose. After we choose the hardware, we use the relevant algorithms. Okay, this is the end of for this capture this chapter. This chapter. Hello.
Hello, Laoshi.
Let's check your assignment. Check your assignment.
Okay, Laoshi.
Okay, Laoshi.
This assignment, just give me the document, not include including the
Laoshi, I send you
project.
on WeChat. I send you on WeChat, Laoshi, because my email have a problem. That's why I send it a lot.
You
You
send
can
me
check
by
your
the
WeChat.
WeChat.
Yeah. Yes, Laoshi.
Okay.
You can also open another one.
Which I open my WeChat.
What?
Oh, okay. I saw your project.
Oh, Laoshi.
This is your project.
Mm.
Can we send it on WeChat?
Sorry, you better send me by the email. Because WeChat there is some problems with the transfer for transfer the files. You can see that if
I will
you
send
want
it-
to
I will
receive
send it
the
on email.
this files, we need to wait. We need to wait.
Yeah, okay. I will
Mm.
send on the email.
If I want to check the cannot accept the files.
Okay, okay, 老师。
This is oh, sorry. I cannot access the Google Drive. I don't know.
It's me,
Who is?
Laoshi. It's me.
Okay, I cannot access the Google Drive.
How will I send it again? Okay, Laoshi, I will try now to send it in another way.
You can send the project as the attachment attached.
Okay, Laoshi, right now. You give me two. Give me two. Which one? I don't know which one is right. I don't know which one is right. That is not me. It's Lydian.
This one.
Yeah, this one is first homework, and the second one is the second homework.
Two
Just
homework.
only one remain.
Okay.
Laoshi, those two are my work.
This assignment for Suhan.
Yes, Laoshi.
I cannot access the Google Drive.
Why, Laoshi?
I cannot access.
What they're saying, Laoshi? What problem? Because I sent last year, it's the same.
You need to attach your files in the email, not use the Google Drive.
But if the file is more than 25 MB, then you can send it without Google Drive.
This file is exceed
It's for,
the
it's
exceed
more
the
than
limit.
40. It's more than 40 MB.
14.
40.
40 MB.
Yeah.
Yes, Laoshi,
40,
mine also.
40 MB. If your files exceed the 40 MB, you divided your files into the smaller package.
Okay.
Smaller package.
Okay, I understand. I understand you. Okay, Laoshi.
Okay.
I'm sending again.
I suggest you use the different name for your assignment. If your assignment use same name, I'm not sure which one is right.
Okay, Laoshi, I will try to resend mine again.
Okay, Laoshi, I understand. Laoshi, sorry for interrupt. Are you hearing me, Laoshi? Laoshi.
right?
Yeah, I sent my all file last semester the same way. So even I don't know you opened it or not.
Oh, you mean you send it twice?
No. I mean our last semester, all of my assignment, I sent you in the same way.
You send it the same way. Okay. I don't know. I don't remember. How to get access to the Google Drive. But
Google Drive.
I hope you can not do it again.
Yeah, sure. I'll send
Access
you
Google
again. But
Drive
I'm
is difficult for us to do that.
yeah, I understand. But I'm worried about my last semester because I sent in the same way.
Okay, maybe I found some method.
Okay, I get you, Loshi.
Loshi, even me, last year I sent like as a Google Drive because the file was so heavy, Loshi.
You give me the files in the Google Drive. I cannot access it.
Last semester was the same.
Last semester is the same.
Yeah.
Last semester is same, but I found another way to access the Google Drive, but in China, access the Google Drive is illegal.
Oh, we didn't know.
Sorry.
That's true, Loshi. It's illegal. Yeah.
This is a assignment. You give me the PDF.
Well, Laoshi.
Yeah.
Laoshi, please can you go up a little, down a little, previous. I saw my name and it just passed. Laoshi, can you
Yeah,
scroll?
it's the same, Sally.
Same what?
He can't access your file, even for us file. He can't.
I can download that. I can download this files.
But Laoshi, I sent you my own on WeChat.
You send me on WeChat.
Yes. King Zell. Sally Zell. There. There. Yes, Lord.
WeChat.
Okay, Laoshi.
Okay. This no more. No more for the assignment.
Even my brother was scammed before. The thing in Ghana is people scam through help because now everybody has come to know.
Charlie, please.
Yoshi,
Yeah.
please, how about those that we sent in a in a way that you say you cannot open. Can we send again?
You send me again, okay?
Okay, thank you.
Okay, this is all assignment that I have received. So if you your assignment I cannot access, if you send me I hope you can send me before this night before this night.
Yeah, sure, Loshi. We're sending.
Okay.
Yeah.
Yeah, we're gonna send before tonight.
If you send me tomorrow, I will reject the
Okay.
Okay.
Okay,
Yeah,
Loshi.
Everyone.
Yeah.
So much for today.
Thank you.
Yeah, Loshi.
Thank you for
Okay,
your
Thank you.
concern.
Yes, Laushi. Yes, Laushi.
Thank you,
So,
Lashi.
You can check your assignment.
okay, Laushi.
Okay.
Okay. See you
Okay,
next
Lashi.
Okay.
week.
Thank you.
See you next week.
See you. See you. See
See
you.
you.
See you,
Yeah.
Lashi.
Anakosa.
You said
Porra.
what, Bob?
Sally.
Yes. ¿Cómo estás?
Toha,
I'm coming.
Más
What?
¿Cómo
cómo
estás?
estás.
Toha,
What,
Estuvo
bro?
bien.
bro, he
Hey,
opened
Lava,
my
say
file.
malo.
Uh-huh.
Say
Did
malo.
you see if my
Open.
file Laushi open it?
Lava, Laushi didn't see your
No,
file.
he
Come on
can't.
for that.
You have
Man.
to make
But
him
Sally,
too
also
fast.
you
So
have the
speak fast.
same problem.
Hey,
I
why are
don't
you
have.
guys
I sent my
shouting?
own on WeChat. He took
The
mine.
way Richard Lashi say he don't want WeChat.
I already sent it, so he took mine. I sent before I sent on email. So you can reduce the file, divide it into two, and then send it at the same time.
Come on,
So
divide
it's
my file.
I'm gonna be quick. Okay.
divide the file into two. You feel me? The size will
Okay.
reduce, then you can send it. But send it at the same time. So that
Guys, where were you
so that
when you
you'll
were
be
learning computer science?
who and who?
That they are asking you, they are disturbing you.
Get out. The people that they're asking you.
Where were you
Charlie,
when you were
guys, good night, good
computer
night, good night. See you
science?
guys.
Good night, guys.
Au revoir, avec encore. Tout le monde pas cassé arriver les dormir.
No, stop. Don't.
Sally,
55,
don't break our
55.
language, please. Don't break